afternoon, everyone. A warm welcome to all of you for joining us today for the sixth edition of the Smarter Conversations webinar series by AMNS India, proudly presented by Magnelis. Smarter Conversations is a platform where insights that build and ideas that inspire come together as we engage with thought leaders who are shaping smarter, safer, and more sustainable futures through design, innovation, and engineering. Today's session focuses on a topic that deeply impacts how our cities and infrastructure evolve towards safer mobility, integrating audits, analysis, and safe system principles. We are privileged to have with us Mr. Suvendu Seth, an accomplished transport planner with over 35 years of global experience in transportation engineering and planning. Suvendu holds a master's degree in transportation from the University of Texas, Arlington, USA, and has led major projects across USA, UK, Africa, South Asia, and India, working with institutions such as the World Bank, ADB, and JICA. He is certified road safety consultant, a professional engineer in both India and USA, and a member of the technical committee of the India's Road Congress. His deep expertise in multimodal transport systems, road safety, and transit-oriented development make him the perfect voice to guide us through today's discussion. So without further ado, let's welcome Mr. Suvendu Seth as he takes on through today's session on safer mobility and integration of safe system principles. Over to you, Mr. Suvendu.
Thank you. Thank you for the kind introduction. Yeah, I can see there are quite a few people out here, 47. Yeah, and welcome to this presentation today. A very important topic. And thanks AMNS India for arranging this webinar today. So I'll be talking about road safer mobility. And I'll touch on the audits, analysis, and safe systems approach, as already Dipal mentioned. Okay, before I start off, let us have the first poll to see how people understanding is about road safety. Can we have the first poll, please? Who are the vulnerable road users? What do you think? Who are the vulnerable road users? We'll have a minute for doing this. Can we see the results of the poll, please? All the above, 59%. Well, the answer is all the above, 59%. Pedestrians, cyclists, and motorcyclists. I'm surprised nobody said cyclists. Yeah, I'll move on. Actually, by vulnerable road users, I mean, what is meant is that all the people who are most vulnerable on the road, those people who walk or cycle or even the two-wheelers. Because if something happens and any vehicle comes close to them or touches them, they'll be the most affected. People who are inside vehicles like a four-wheeler or buses, they're much more protected. But these people are exposed to traffic. So that's why the term vulnerable road users is used. Okay, moving on. To give an introduction to the global situation on road safety, what we see is that road traffic injuries is the leading cause of death amongst children and young adults. And these are the productive people, starting all the way from 5 years old to 29 years old. And it is the leading cause of death for all people of all ages, 12th leading cause. And these statistics are quite scary. 1.19 million people die from road traffic crashes all over the world. 30% are the two-wheelers, the motorcyclists, and three-wheelers. So we can understand that this is a problem globally. Now, if we look at the situation more in details, 92% of the deaths that occur from road crashes are from the middle and low-income group of countries. So we contribute much more to the number of people who are dying from road crashes compared to the total number of motor vehicles that are on the roads in our countries. So this is a scary piece of statistic. The pedestrian facilities are around 21%, cyclist facilities are 5%. And in the lower middle income group compared to high income countries, the chances of having road crashes and deaths are 3 times more. So we have to take care of this situation. Taking an overall view of the Indian situation, from the global situation to the Indian situation, we have 63,000 kilometers of roadway, only the second largest in the world after US. We have the national highways, the state highways, and the rural highways. And rural highways contribute to the maximum kilometers of roadway. And these are the village roads, the district roads, other district roads, and so on. And then we have the state highways and the national highways. If we look at the statistics for crashes in India over the last few years, we see that the total number of people who died, that's shown in red, the fatalities, which is around 1.6 lakhs, more than 1.6 lakhs in 2022. We can see that the total number of crashes are to the range of 4.6 lakhs. Injuries are to the 3.9 lakhs. All these are huge numbers. We had a little dip in 2020 because of probably the COVID effect and the lockdown and so on. But again, it has picked up. And these figures are till 2022. I'm quite sure these figures are even higher today as we speak. So we understand there's a huge number. If we have 1.6 lakh plus people dying from road crashes every year, this is a major problem. And globally also, it's a major problem. So looking at this, more to look into details about the Indian situation, if we look at what type of fatalities and injuries and accidents happen in what type of highways, we know that the national highways have a large network. It carries some maximum amount of traffic. It can be understood that the fatalities and the accidents are high on the national highways. But if you look at the rural roads, that also contributes a huge percentage to the fatalities and total number of accidents. So even if we can, these are rural roads, that's the smaller roads, which are narrow, smaller village roads and district roads and so on. Even that contributes a great percentage towards the deaths and the injuries. Now, even if we can handle that, we will be solving more than 40% of nearly 50% of the problem related to traffic crashes. Then of course we have to take care of the state highways and national highways, but national highways are high-speed facility and investments are higher there. But in spite of that, we have huge number of fatalities and crashes. Now, understanding that this is a problem worldwide, the United Nations took up this action plan, even decade of action for road safety improvement. This was started in 2011, was supposed to be till 2020, but it's been extended to 2030. And all the countries that are part of it are expected to take up this following actions, in terms of road safety management, in terms of safer roads and mobility, safer vehicles, safer road users, and post-crash response. I'll be touching on all this in my presentation today. The global plan is reduction of crashes and deaths by 50% by the year 2030. This has been signed by several countries all over the world, most of the countries that are part of UN. India is also signatory to this. So that is our goal of reducing the total number of crashes and deaths and injuries by 50%, at least by 50%. And we are trying to reach that. So how can we reach that reduction by 50%? There are several ways of handling this, and I'll be talking about some of the ways. So before we go into the next thing, can we have the next poll, please, to have an understanding? How many people approximately die in road crashes? I touched on this a little while ago. Let us look at the result for what people think. 1.19 million is the approximate number as estimated by the United Nations. Most people said that. Yeah, that is what I mentioned also. Yeah, so okay, moving on. As I said, this is the global plan of reducing the total number of crashes, deaths and injuries by 50% at least. And there are several ways to do it, and that is what I'm going to talk about today. And when we talk about road safety, there's this 5E model. Traditionally, we talked about 3 E's: education, engineering, and enforcement. These are the 3 E's that we talked about. Now we have added 2 more E's: emergency care and empathy. Education is educating the people how to use the road properly, how to drive properly, and so on. Enforcement is obviously police enforcement of the rules and regulations related to traffic. Engineering is designing, constructing, maintaining, and operating the roadways. And with it, there's an emergency care. Now, we are aware that if there's an accident and people are injured, if we can reach the medical care to them very quickly within that 1 hour, golden 1 hour, then there's a very good probability that we can save lives. But as the time goes on, the probability of saving life goes down. And empathy is other human factors. There's various human factors that are related to driving, the behavioral pattern and how people interact with other drivers. And this is also another very important E that is a part of the model. We have to look at all these aspects in order to bring down the accidents by 50% and the deaths by 50%. So moving on, we have basically 2 ways of handling this. There's a reactive approach and a proactive approach. In the reactive approach, we look at the total number of crashes, where it occurred, we collect data, we analyze and try to find out how to solve it, what actions to take so that these accidents do not happen. That's the reactive approach. The proactive approach is looking at the situation before the accidents happen and to see how we can prevent the crashes even before it works, before the crashes happen. So these are the 2 major ways of handling it. And there is also something in between, a portion of reactive and portion proactive. I also mentioned that. The reactive approaches are, one of the things is black spot study, which is based on data collection, analysis, and finding out solutions. The proactive approaches are road safety audit, safe system approach. I'll be talking about all these 3: black spot study, road safety audit, and safe system approach. And there's a mixed approach also. which is IRAP, International Road Assessment Program, where trained professionals go out and travel the roadway and find out what are the and mark those roadways in terms of 1-star, 2-star, 3-star, and so on. 5-star being the best, the safest, 1-star being the least safe. So that is a combination of proactive reactive approach. So today I'm going to restrict myself to the reactive and proactive approach and talk about these three approaches. Before we go into the crash analysis, can we also have this third poll, please? Yeah, we just to discuss this. You can see what how people have responded. What is a proactive approach? Proactive approach is the road safety audit approach between these three. Because as I said, black spot study is based on data collection. I'll go into details of it right now. And IRAP is a mixed approach. So the answer is road safety audit. So these three I'm going to talk about right now. Crash analysis is the steps to crash analysis is first of all identify where the crashes occur, then quantify the main crashes, how many crashes occurred, what are the sources of the problem, why it occurred, evaluate the various improvements so that the crashes can be reduced, obtain expert opinion of how to do the improvement, and then get funding to implement the safety measures. This is a very important step because unless we implement the solutions, the situation will not improve. Even if we have done the study, we'll just keep the report in the shelf, nothing will happen on the ground. So this sixth step is very important. This is one of the examples, one of the tools that are used by road engineers, collision condition diagram. This is the left side. It is mid-block sections where we have shown all the crashes, different terminologies like rear end crashes, left turn crashes and all that. And we've shown that pictorially where it occurred. And the right side diagram is at a junction, what type of crashes occurred, side swipe or rear end and so on. And with this, we also mark the date, the time. Okay, so that by looking at this figure, one can understand what exactly happened in that area, where the crashes happened, at what time it happened, what type of crashes. Gives a very good pictorial representation, collision and condition diagram. And then causes of, once we go into that analysis, we first have to look at what are the various causes of road crashes. The major causes are road users, vehicles, condition, it could be roadway design, it could be environmental factors or any other causes. By road user causes, we know all this, that excessive or rash driving or high speed or violation of traffic rules or fatigue, alcohol, sleep. These are all the major road user causes. Vehicle causes could be failure of brakes or steering system or lighting system and so on. Road conditions, we are also aware of it. Skidding roads or potholes, vehicles trying to avoid potholes and therefore having a crash with another vehicle. And roadway design problems are maybe the side distance was not enough or the curve was too sharp for that design speed, or traffic control devices were not proper, there were no lighting provided. These are all the road design aspects. And then environmental factors are there was heavy rainfall, so the visibility was poor, or there was snow or mist or smoke, this kind of environmental factors. This normally relates to the visibility getting reduced and the driving conditions becoming unsafe. And other causes could be various other causes. The two examples I've given here: improper location of advertisement board. This is often seen on Indian roads. We have a very important junction, the critical position, there's a big hoarding. So the vehicles driving on the main road cannot see that some other vehicle is entering from the minor road till the last moment, and there could be a crash. So this is some cause. Or it could be that the level crossing was coming down, the gate at the railway level crossing was coming down very slowly, and the vehicle entered the railway lines, and then there was a crash. So these are some other causes, but primarily it's roadway users, vehicles, conditions of road design, and environmental factors. If you look at the percentage, human factors contribute to 95% of the causes for crashes. And there are overlaps between environment factors, vehicle factors, and so on. If you look at just simply the human factors, it is 65%. But combined with others, it is 95%. And if you look at all the three together, that's a small number, 2%, which is human factors plus environmental factors plus vehicle factors. Normally, it does not happen, all the three together. Normally, it's the human factors. So these are the major causes of crashes. Crash data collection, the first thing that a road engineer does is identifies where are the hazards, which places the crashes are happening. And this is usually from the police records. Police keeps the record of crashes, and the road engineer has to collect this and then put it on the map to see these clusters, which areas are hazard locations, and then find out what exactly is happening. Why are the crashes happening? So there are various types of data that have to be collected. The very basic thing, the first is general data. Like what time did it happen? Which day did it happen? Time and date are important because a crash that is can happen in the evening or in the morning because of certain lighting conditions or certain environmental conditions. So it is important to find out when we are trying to do investigation of why a crash happened. It is important to know what time it happened and then the date, because from date we can understand if it's a working day or a holiday. Then the nature of travel is different, so that can tell us why a crash happened. There's some important information like the personal information, the driver, male or female, young or old. These can give an indication of driving nature. Classification of crashes. Crashes can be either fatal or serious injury or minor injury, or it could be just plain simple property damage. So these are the first type of information that one collects. Then the location. Location is very important. Where exactly did it happen on the road? The exact chainage. Normally, this has been our weak point, because the police records usually does not give an exact location. It gives 50 meter from this particular landmark or 70 meter from there. This doesn't exactly tell you where the location was of the crash. If we do not know it, investigation becomes very difficult. Nowadays, with the present system of recording, where the police are doing it with the handheld GPS, they're getting the exact location. Therefore, it's much easier to plot it on the map and see exactly where the crash occurred. And therefore, we can get the cluster and then do a better analysis. If we do not have a good idea of the location, analysis is not right. Then we need also to have this vehicle involved, what registration number. This is more important for the police. But type of vehicle is important, because if it was a heavy vehicle versus a light vehicle versus a two-wheeler, then it is important for engineering analysis, and whether it had at all any vehicle defects or not. Then the nature of crash, detail of the collision, what kind of damage happened, were people injured, how many casualties. These are all a part of crash data collection and then subsequently analysis. Now we're coming to the black spot. Black spot is a spot where number of crashes happen, a cluster of crashes. That's a black spot. There are various ways of finding out which one is a black spot. In India, we follow the MORTH protocol, which was formulated under the Supreme Court guidelines. Any spot where 5 or more accidents happened in the last 3 years can be called a black spot. Or any spot where 10 or more deaths happened in the last 3 years, or a combination of both, then it can be a black spot. So this is defined, and that's how we look at identification of black spots. Once we get the data, we look at the locations. By location, I don't mean just one spot. It could be one region, a 500 meter this side or that side. That's how it is dealt with, a spot. And then we have to go and do the investigation of the black spot. To treat crash analysis, the process is like this. First of all, decide the criteria of listing crash locations. This is, as I said, our protocol is, in India, we have this protocol for finding out how many crashes happened over the last 3 years, which spot, if the 5 and 10 rule, 10 deaths or 5 crashes, and then list all the crashes. And then the team has to go out to do the investigation at the site, obtain all the relevant information from the police, go to the site, see what exactly is the situation there. So like, be a detective, find out what could be the possible cause of the crash, and then find out solutions. What could be the countermeasures to avoid this again? Match the solution to the problem. Then design for that solution. Prepare a preliminary design, have a detailed design, complete the design, and then it will go for construction. But for doing that, we need to have funds. And for doing that, normally a justification is required. What is the benefit cost ratio? If we do something versus do not do anything, then we have to document it and ask for the funds to take care of this. Unless some action is taken, there's no point doing it, because it will remain a paper exercise. Then if there are multiple locations, multiple black spots, then we have to identify which one should be taken up first. Prioritization has to be done, where everything cannot be taken up together. So after that, implementation of the treatment. Whatever treatment we have developed, designed, then we have to implement it on the ground. And then a very important part, once the implementation is done, monitor that location for at least 1 year and evaluate whether the treatment, whatever we proposed, is it working or is it not working? If it is not working, then there was something wrong. We need to take further action and change the design or do something else. So this is how we do crash locations and treatment. Now I look at mitigation measure. Before doing that, let's go into another poll, the last one probably. Can we have the poll, please? Yeah, safe system approach. I haven't gone to that, but I would like to know what is your opinion. Is it an engineering approach? Let us see what is the response. Most people think that it is an engineering approach. Well, it is not just an engineering approach. I'll talk about the safe system approach. It is a combination of various things. It's not just an engineering solution. Okay, I'll go into it a little later. But before that, let me talk about the mitigation measures and how to handle it after done the crash investigation and analysis. The left-hand side, this is an existing situation, a road with a Y junction, and then there were several crashes here. So it was identified. On the right, you can see there have been improvements done to this Y junction, and I'll go much more in detail here. The next slide here. See, this Y junction has been improved. Well, there have been several signs put up for guiding the drivers, and then pedestrian crossings have been put up, islands have been created, and several types of markings and signs have been put up. So this is to guide the traveling public better. By traveling public, I mean all the road users, the people who are driving, the two-wheelers, or pedestrians or cyclists, for everybody. So these are the signing and marking and safety features that have been put up to reduce the number of crashes at this junction, because there were a lot of crashes happening. Okay, so this is one of the example junction improvement which comes out of black spot analysis, the one spot improvement. Well, here I have to talk about the relevance of crash barrier. Crash barriers are important because they can reduce the crashes, especially when there's a high embankment very right next to the side of the road, and if there is a narrow shoulder, vehicles can run off and fall down. Crash barriers can be of various types. It can be rigid, it can be flexible, or it can be semi-flexible. And usually we use steel crash barriers, which can direct the vehicles to the main road. And there are several types of crash barriers, and various modern technology are available in production of this crash barrier. Magnelis is one such product which uses zinc, aluminum, and magnesium, and this gives better long-lasting life, and it reduces the cost on overall installation maintenance. So this is one of the important products of crash barriers, an important safety product. Going over to the next aspect, which is road safety audit. Now, as I said, road safety audit is a proactive method. It's a formal process. It is not an ad hoc process. It's a formal process of doing an auditing of the road. It kind of finds out what are the possible chances of accidents occurring and where it can occur. And this road safety audit can be done for various stages of roads. It can be for operating roads where existing traffic is flying, or it could be for future roads which are under planning and implementation. It could be traffic related projects or various road users. Now, very important point is road safety audit is an important input into the design, but it is not a part of actual design. It focuses primarily on the physical elements of the road and tries to find out how to minimize the number of crashes from happening. So I'll go into more details of it. The aims of road safety audit is minimize the risk of crashes to happen, and even if the crashes happen, the severity should be minimized. Okay, first we'll try to avoid the crashes, if not possible, at least minimize it and reduce the severity. And this is for all the road users. It is not just for the vehicles, for all kinds of road users, and reduces the long-term cost of schemes, because if we can do it from the beginning, then the later on actions of crash investigation and modifications that will be avoided, and also improves the awareness of safe design principles. These are the aims of road safety audit. Briefly into the details of it. The difference between crash investigation, which I talked about earlier, and road safety audit. The idea is prevention is better than cure. In crash investigation, what we're doing is we're looking at the crashes that have already happened, trying to find out why those happened, and trying to find out measures of how to prevent it. But in road safety audit, we are not doing that. We are looking at the road, traveling the road, and finding out what could be the possible flaws and try to prevent accidents from happening at all. So that is the basic difference. Now, the next question is, who can do the safety audit? Can anybody do the safety audit? Well, we need to have some training for this. But the important part is it must be independent of the design team. A design team who designs the roadway can never do an independent audit, because they'll never be independent. If you have designed a road, however much you try to be independent, they will be partial towards your design. So it's always independent person who comes and does the audit, not the design team at all. And a small team of auditors is required. At least 2 people. Better if we have 3 or 4, but at least 2 persons, because we can discuss, and it's not one person's whim. We can have a discussion and have the solutions. And out of those at least 2 people, one should be an expert. That is, one should have the proper training and experience of doing road safety audit. People can be from highway or traffic engineering background, the road safety education with maintenance background, or even traffic police can be brought in as a special person to do the road safety audit with a team. So this is it. This is how the road safety audit gets done. And it can be done for various stages of audit, starting right from the feasibility and all the way to the existing roads. At the feasibility stage, we do audit of the proposals that are going to be coming up, the road projects that are supposed to be coming up. Preliminary engineering, when we do the engineering, then an audit can be done. In detail engineering stage, it can be done. Then during construction, at various stages of construction, an audit can be done. And then just before opening the road to the public, pre-opening stage audit can be done to see that the road is in proper shape to be open to the public. Then after that, after the road is in operation, as an existing road, audits can be done. Obviously, the focus of audit will be different. At feasibility study, it will be different from detail engineering study or at the existing road. So that is the details of how to do audit. I'm not going into the detail of it. I'm giving an overall idea of what road safety audit is and how it gets done. Requirement of auditors, as I said, they have to have certain skills. Team leader, at least 2, and then team leader, preferably 3 to 4 people audit team. The team leader should be skilled with sufficient experience and training. The team members assist the team leader. And carrying out site inspection is very, very important. You cannot have an audit done without site inspection. And this is during the day and during the night, because any road can look safe in the day, but the situation changes completely at night. And the result of the audit is a formal written report, which is submitted, identifying all the flaws with pictures and saying why it is a hazard, safety hazard. So that's how the report is prepared. I'll show you here some examples. The top left-hand side, this is a very common scene on the Indian roads. This truck has turned over, and then we have several rocks they put in there as impromptu measure. But this itself is a hazard. This rocks on the road itself is a hazard to the passing vehicle. This can be covered in the existing road audit where some accidents have happened. On the top right-hand side, see there is a median with a drop in level. Now this should have been noted during design. This is a hazardous design. Vehicles can steer off and fall there, and there can be serious injuries to the people in the vehicle. So this should have been caught during design. This is not a safe design. Bottom left side, the trees have been cut and they're left on the shoulder. This is also a possible hazard because vehicles can travel and hit this road, especially at night, and this can lead to injuries. On the right hand side, you can see there's a narrow road coming and meeting a major road. There is no access control, there is no signing, no marking, no warning. Especially at night, this can be hazardous. So all these things can be caught during an audit, either design stage or whichever stage you can be in. Moving on to some other pictures. Here on the left-hand side, you can see that there was a guardrail there. It was hit. Now it's damaged and it's lying like that. And there's a rock or a rigid structure right before the guardrail. This is a very dangerous situation. A guardrail works with the principle that a vehicle, if it hits it, it is directed towards the road. Okay. But if the guardrail is broken and is not replaced, the function does not get served. The vehicle will just fall down in that embankment, down the embankment. Or if there is a rigid body in front of the guardrail, then the whole purpose is defeated. This should get caught in audit. The right-hand side picture, this shows this is a winding road. There is no warning sign. The driver is not at all warned about what is lying ahead. Sharp bend. Visibility can be restricted, especially at night. So these things can be caught in road safety audit at various stages. This one other picture here on the left-hand side, we have bad condition of road, very poorly maintained. Vehicles try to avoid these puddles and they'll go to the other side. They can have a head-on collision. On the right side, we have a picture of this transformer put right in the middle of the median. This is a hazard. Vehicles can come and hit the transformer. There will be serious consequences. There could be fire, there could be electric shocks. Several people may get injured. So this should have been caught right at the beginning when the plans were getting prepared, that these transformers cannot be in the middle of the road. So that is the necessity of having audits. These can be caught beforehand, because after that, if you want to remove this transformer, it will be a very expensive proposition. So I'll just go into the safe system approach. Safe system approach is also, again, not a reactive approach, it's a proactive approach. Safe system approach is an effective way to address and mitigate risks inherent in a transportation system. Now we'll go into more of a systems approach out here in safe system approach. Now it works at building and reinforcing multiple layers of protection. The whole idea is if you have multiple layers of protection, even if one fails, there will be another level of protection. So you will be safe. It's a very holistic and a comprehensive approach to look at safety. And the difference from the conventional approach is, as I said earlier, we look at human mistakes, human errors whenever crashes happen. what were the various human errors. But instead of human errors, in safe system approach, we look at human vulnerability. We look at the vulnerability side instead of the error side. And the design is done in such a way that there are redundancies, as I said. So one thing fails, there's another thing to protect you. This is the overall approach of safe systems. It works at various levels. The idea is to have 0 fatalities and 0 injuries in future. There are various aspects. That's why I said it's not only an engineering aspect. It looks at the infrastructure, which is related to engineering, but it also looks at human behavior, vehicle technology and engineering, emergency response. That's why the medical facilities come in. So there are various things put together in safe system approach. The principles are that death and serious injuries are totally unacceptable. Even one death is too many. The idea is to have 0. And the next important, very, very important principle is humans will make mistakes. Everybody makes mistakes at some point in their life. Even if they have the best drivers, they've been driving for years, but still at one point they can make a mistake. And it should not be that because of that mistake, the person will lose their life or lose their limb. So we have to accept that humans will make mistakes. And then important thing is humans are vulnerable. Human body can only tolerate so much. If there's an impact at certain high speed, human body will not be able to tolerate it. And human body will fail, therefore resulting in death. So these will have to be accounted for while designing. And the design will have to be human-centric and accommodate human vulnerabilities. Another important principle is responsibility is shared. It is not the responsibility of only the engineer. It is a responsibility of everybody. The government who provides this service, the industries who provide various components for safety, the non-profit or the advocacy groups which they'll propagate the various safety measures and approaches. The researchers will bring out the developments and how to improve. And the general public or the users, they will have to be taught, they will have to go along with this, they have to follow that so that the number of deaths and injuries are brought down to 0. So everybody is responsible. And safety is proactive. Here we are looking at completely proactive tool. We are not waiting for the crashes to happen and then take reaction. Then we are anticipating what kind of crashes can happen, and therefore we are taking measures. And we are taking redundancy so that if one thing fails, another thing kicks in. So these are the approaches, and the various objectives are safe people, safe roads, post-crash care, safe speed, and safe vehicles. I'll go over it slightly in more detail. For safe people, we're looking at encouraging safe and responsible driving behavior. These are human factors come in here, training comes in here. Another important, create conditions so that destinations can be reached safely, right from the home to from the origin to the destination. The entire route has to be designed in a safe manner. Safer roads the environment should be safer so that even if human beings make a mistake, they do not end up with being very seriously injured or dead. Injury tolerance should be brought into the safer road design, encourage safer behavior, and facilitate safe travel. This is also for the most vulnerable users. We have to look at the most vulnerable users first, because if something happens to a pedestrian, there's a very good possibility that pedestrian may not survive. Going on to the safer vehicles, these are about the vehicle technology. There are multiple safety features that are available in the vehicles today, and with time they're going to be even more, so that they can reduce the impact of the crashes and save human lives. Safer speed, this is for speed which is equitable and contextual depending on which road we are driving on. I'll talk about speeds more in detail a little later. Appropriate speed limits should be set depending on what type of facility we are driving at. And then targeted education, outreach campaigns and enforcement, all these are important to have safe speeds. Post-crash care is very, very important because we know of this golden hour, fast access to medical care. If we can reach the victim within a very short time, very good probability that we can save the person. We have to have network of first responders. We have to have, and another important thing is whenever a crash happens, usually there are secondary and tertiary crashes because the vehicles which are coming behind, they do not know there's a crash. They come and pile onto it. So these have to be prevented. Quick traffic control measures right after the crash, that is also important. And so this is not only the engineering measure, these are emergency measures also from the law enforcement. Looking at the various differences, what are the differences between the conventional method and the safe system approach? Usually we look at, whenever we look at crashes or accidents, we think the problem is the crash, the way one vehicle collided against the other. But in a safe system approach, we are not looking at the crashes. We're looking at the fatalities and the serious injury. Because the idea is not just to stop the crashes, but the idea is to stop the fatalities and the injuries. Even if a crash happens, if there is no fatalities, no injury, then it can be acceptable. Then the cause of the problem. Usually we all look at speeding, drunk driving, people were not following the rules, and so on and so forth. These we look at the conventional way of looking at the causes. But in safe system, we're looking at this, something happened in the system. Something failed. That's why a crash happened. Because there's a systems approach to the whole issue. Responsibility, fixing the responsibility. We have seen in previous slides that human errors at the maximum, more than 65%. How the crashes are because of human errors. But in safe system, we are saying it's a system designers and operators. There was something that did not work properly. That's why a crash happened. It was not an individual's fault. The major approach, the difference in major approaches, in conventional methods, we look at incremental approach. We try to take measures so that the number of crashes can be brought down. In safe system approach, it is different. We're looking at systematic approach to build a safe road system and minimize the harm so that the crashes and the deaths are zero. So these are some of the differences. We're looking at some more. Conventional system, the goal is to optimize the fatalities. So bring down the fatalities and serious injuries, have an optimal number. But safe system does not recognize this optimal number. Every accident is one too many. So we want to have no fatalities, no serious injuries. That's the goal. The trade-off between the two, it's basically in conventional system, we think of the mobility and the safety and a balance. But in safe system, we are thinking of both together, maximizing safe mobility. Mobility should be in a safe manner, not a balance between the two. And how is it to be coordinated? In the conventional way, we look at incremental gains with individual pillars. We could look at the roads, then we look at speed imposition, speed restriction imposition, then enforcement, then vehicle technology, training the people. We're looking at various silos. But in safe system approach, all is together. Road, speed, vehicle, these are all the pillars, and everything put together is a safe system. So these are the basic differences between the conventional system and the safe system. The cultural manifestations, when talking about conventional system, we talk about the insurance, the risk aversion, who's liable, these issues. In safe system, we're assessing the risk, finding out innovation solutions, making demonstrations and trials to show how it can work. The tools in conventional system are the pre-existing crash history. We have to look at the history of what crashes, how it happened, understanding the causes, likelihood, reducing the number of causes, as we did in the crash analysis. But in safe system approach, we're looking at risk analysis. Based on the network, what are the possible risks? And then this is obviously have to be supplemented by crash data. We cannot do away with crash data. That is a basic pillar. We have to have the crash data because we have to understand the crashes, but then we have to also look at the overall risk analysis. So these are the differences between the two. Now slightly looking at more detail of the safe roads. These are the 5 pillars. One of them is safe road environment is a very integral part of safe system. It recognizes the limitations of human body and decision making, reading, understanding, taking the right decision at the right time. Therefore, these are limitations. So the road should be designed in such a way, it's for such speed that even with the mistakes, one can recover. It's a concept of forgiving design. That is for safe road. Here, the engineer's role is primary. Then there are various countermeasures. There's some countermeasures given here, like proper lighting on the road, safe crosswalks, pedestrian crossings, bicycle lanes, or separated bicycle facility. Because at certain low speed, bicycle lanes are all right. But high speed facility, we have separated bicycle areas so that the bicycles are safe. Then redundancy is critical. We have to have multiple things so that if one fails, the other kicks in. Then safe system treatment for crashes. How do we treat crashes? We have looked at the black spot analysis and how to address the crashes. Here from safe system approach, we can look at runoff crashes. Runoff crashes are vehicles will run off the road. We can have center line and edge line barriers. That's where crash barriers can come in. At the intersections or junctions, if it's a roundabout, we can have deflection angles which are wide so that the vehicles can come in and slow down at the roundabouts. Then we can have raised platforms at the intersection so that they cannot run over it. We can have separate left turns or separate acceleration lane or deceleration lanes so that The vehicles entering in the roadway do not have to enter into a live traffic. They can have a separate lane. Then a grade separation. Grade separation is only recommended when the traffic volume is very heavy and the speed is very heavy and mobility is very high. Other than that, it is not advisable to have a grade separation everywhere and anywhere. For a head-on collision, we can have median barriers. Median barriers can save head-on collisions. For pedestrians, we can have pedestrian facilities like grade separated facilities or raised pedestrian crossing. Again, grade separated facilities are not very welcome by pedestrians. We know it in our various experiences, all over India. People normally do not use these grade separated structures. People don't want to climb up the stairs, walk across, and then climb down. They would prefer to cross wherever it's convenient for them. So we have to be careful where we give the grade separation. Is it really justified? Will people use it? So it's much better to have at grade crossing, what's easier for people, especially for elder people. So we can provide grade separation when it is absolutely required. Here is an example of a typical diagram versus safe system approach. On the left-hand side, for divided carriageway, we have a wide, median, and then two-lane roads, two-lane roads in both directions. In the same right-of-way, we can have a four-lane road with a wide central median with marking and with sufficient pavement markers and several other measures. And then we can give side space so that we have offset for people to park if necessary, or people to take rest or run out areas. For a typical two-lane highway with one movement in one direction, we can have offsets, we can have the central median markers, we can have wide central median area with marking only. So these are the various safe system approaches that we can apply even within the right-of-way without acquisition of land. Here is a very important matrix of movement versus place. X-axis we have the place parameters and y-axis we have the movement. We see if the movement is high, that is a high speed, large volume movement in the open areas. But where the place parameters are high, where a congested area or the busy central business district, the movement will be low. The balance has to be between movement and place parameters, and we have to have priorities and have speed management, looking at where the location is and what type of movement is going to happen. Safe speed is an important concept because we have to have a right speed in the right area for the place parameter. The speed should be equitable depending on the type of vehicle and type of area. It should be context specific, and people should be targeted education should be provided about the speed, what is the right speed in the area, and enforcement is also required. If you look at the speed, why is speed so important? These three graphs show what kind of fatality can happen for different types of, for pedestrians it's marked in red, side impact collisions between vehicles is in blue, and the yellow one is a head-on collision. We can see from the red graph that at 30 kilometers an hour, the probability of dying from a collision with another vehicle, a pedestrian cyclist colliding with another vehicle, is about 10%. But the moment we go into 40 kilometers an hour speed, the probability jumps to 40%, and it goes on increasing. It jumps because the probability of death at high speed impact for a pedestrian or a bicyclist is very high. But for the other types of vehicle, the speed is much higher at which the probabilities of death is higher. So this is a guidance. This can guide you to design what kind of facility can have what kind of speeds, limits and restrictions for a safe speed. How do we manage speed? There are various traffic calming methods. Engineering literature has it. The various ways of doing it can be speed limit, can be speed enforcement. Behavioral changes are very important, so that's why training is necessary. And nowadays the vehicles also have speed limiter devices and adaptive cruise controls, which automatically restrict speed at certain areas. So these are the speed management measures, and the design philosophy for various road users. For cars, design philosophy establish appropriate speed limits because we know the cars can cause crashes in certain areas, especially in the busy areas. For urban design, reduce the carriageway width. If you reduce the width, speed automatically people reduce this. Limiting the visual length. If you can see for a long distance, you need 10 to speed. Different road surfaces can be used, and various other traffic calming measures can be used. Cyclists are much more vulnerable than cars. When designing for cyclists, design for cyclists as a priority. Think of the cyclist as the main person. If it's a low speed environment, then they can use the facility with other vehicles. But if it is a high speed facility, cyclist ways should be segregated, especially at the busy streets. Even cyclist and pedestrian ways should be separated if there's a heavy volume of cycling and very volume of vehicles, pedestrians. And the connectivity should be from end to end, not just one small section. Otherwise, the cyclist will not be encouraged to cycle. From the start to the end, there should be a safe facility. So that is the design philosophy for various road users. And coming to pedestrians, as I said earlier, pedestrians are the most vulnerable one, that they should be given the topmost priority. And the streets should be designed at the human scale, at how human beings look at things. And it should be based on the needs of the pedestrians. Activities should be encouraged, because when there are activities on the street side, that people are encouraged to walk more. The street environment should be friendly to the pedestrians, and design speed right next to the pedestrian facility should be much less than 25 kilometers an hour. Because of what I told earlier, at 30 kilometers or more, the probability of death increases if there's a collision. Thus, street furniture, the removing of barriers between the people and the users should be done. Normally, we do provide signages for vehicles on the main roads, but we do not provide so much of signage for cyclists. And signages for pedestrians is very rare. We don't provide it. But proper signage encourages proper usage of streets. So that should be encouraged. So these are the design philosophy for various road users. For safe vehicles, we know of this because the safe vehicles are dependent on the age of the vehicle, how good it maneuvers, visibility, braking, and various other safety features that come in the modern vehicles. The newer vehicles have various safety features built in, which older vehicles did not have. But that's a safe vehicle pillar of road safety, of safe systems approach. And these are the various technologies: stability control, fatigue warning. If you have had a drink and then trying to drive, the newest cars, they'll warn you. Then there is automatic crash notification system, and the autonomous vehicles are very soon coming to India. So there'll be driverless cars also. So the various technologies available, these are all vehicle safety and vehicle technology. These are also engineering aspect, but not from a civil or transportation engineer, but more for vehicle engineering. Then coming to safe people, how do you make the facilities safer for people? As I was talking earlier about this, various aspects of road. If there's a long tangent straight section, then people will tend to accelerate, speed up. But if the tangent sections are short, the speed will be less. If there are speed limiters, then the speed will go down. Openness of the situation, in wide, vast, open spaces, people tend to speed up. With narrow roads, people try to slow down. We can have various road surfaces, rough road surfaces, so that people slow down. Smooth, nice road surfaces, people tend to speed. So these are for safe people approach, bring safety into designs. Behavioral aspects, as we know, no drinking and driving, child restraint system, we normally do not use it. Helmets, we have started using it, and there are enforcements. Use of seat belt, there are enforcements, especially for the front seats, but even back rear seats, seat belt use is necessary. There are speed zones, encouragement of safe driving through education. These are all the human behavioral aspects to safety. Then emergency aspects, as I said earlier, that we have to reach the emergency facilities to the people who have been injured very quickly on the scene in a timely fashion. For that, we have to have trauma centers spread out all over, especially near the major highways. Then post-care facilities, post-trauma care facility. And then very important is performance measurement of emergency response. We must have a proper performance measure to see whether our emergency response system is working properly or not. If it's not working properly, we have to take some other measures, but we have to know about it. Vision Zero is an extension of safe system approach. It was developed first in Sweden in the 1990s, and it moved to other parts of Europe and then North America, and now it's all over the world. The difference, just like the safe system approach, Vision Zero thinks of preventing all deaths and injuries, or traditional way of looking at accidents, as we call it. Accidents was Accidents are inevitable. If people are driving, there are bound to be some collisions, some accidents, but Vision Zero does not accept that. It wants to bring all deaths and injuries to zero. And that is a traditional departure. Vision Zero is a multidisciplinary approach, just like safe system approach, and recognizes that people will make mistakes and the redundancy is brought in, just like safe system approach. And Vision Zero is not a slogan, not even a program. It is fundamentally a different way of approaching traffic safety, about safe mobility, not just about mobility and not just about safety. It's about safe mobility. All the people are, all things are together, building a sustainable leadership, collaboration, accountability. And again, data analysis is necessary, but we should not be neglecting the reactive ways of collecting data and analysis. That is important. Equity and community engagement should be given priority, speed management, and setting a timeline for zero deaths and serious injuries. That is the strategy for Vision Zero. That is it. Thank you. If you have any questions.
Yeah, audience, we have limited time. Please put your questions in the questions box. Yeah, Mr. Suvendu, Engineer Hemant Vadalkar is asking, why can we not eliminate black spots during the design stage itself?
But as I said, black spots are first of all identified after the road is in operation. There are certain deficiencies. That's why the concept of black spot comes in. If we can eliminate it right at the design, that will be even better. But how do we do that? And road safety audit is one of the methods. That's a proactive approach, taking care of this problem before it has happened. But black spot analysis is the reactive approach, which is after the situation has happened, then we are taking care of it. Obviously, reactive approach is much better. It will save lives.
Mr. V.N. Rao is asking, why are there up and down formations in the Indian roads? Why are roads made with more curves even though there is sufficient space available?
Up and down, and I think you mean the vertical profile, right? The vertical profile, and then you're meaning the horizontal profile, the curve.
Horizontal,
right?
Yes.
Horizontal and the vertical. Yeah. See, this is a road design aspect, and when a highway designer designs a road, the road has to be within a certain right of way. If there are constraints in terms of land, then there are certain curves that need to be provided. For the curve, the radius of curve, and the transition length, and the type of roadway, and this are all a part of designing the road. As far as the vertical geometry is concerned, it is governed by the topography. If the topography is such that the road has to go up and down, then that's how it is designed. Because if you have to cut it, it will become very expensive. If there's a hillock, and you cut the hillock to make the road flat, it becomes very expensive. And if you have to make too much of high steep up and down, then that is also not safe. So there is a balance between what is economically acceptable, what is in the safe way of doing things. That's why I said it's a compromise between the two. That's how we have always designed it, in terms of cost, in terms of safety.
Mr. Nilesh Shingade is asking, in India, major number of deaths is happening due to potholes and bad roads. This may be due to corruption between the departments. Is there any solution for this?
Well, if you remember, I showed the graph where the major causes are shown, and that is worldwide. That includes India also. And we see the major cause as it is today are the human errors. Okay. Yes, the road environment does have an impact, but that percentage is much lesser. Okay. And as far as potholes and repairing these are concerned, yes, these are issues of construction, maintenance, corruption sometimes comes into the picture. Yeah. What we can do is we can have much stricter regulations regarding construction, regarding material, regarding maintenance, and also defect liability period. These are all a matter of contract management and doing the work properly.
What are the typical challenges to road safety? Where is India weak? What are the weaknesses in the Indian systems for road safety?
The last few years, we have been serious about road safety because we know that there are, as I said, more than 1.6 lakh people are dying every year on the roads. This is a very, very bad situation. So we have woken up to it. But sad to say, we talk a lot about road safety, but we really do not take proper action. As I said, unless you implement it on the road, the situation is not going to improve. You can do a study and keep the report on the shelf. That will not improve the situation. A lot of time that things happen. Secondly, a lot of times we do road safety audits, but do not implement what has been recommended. Okay, so that doesn't help. And as I said, a lot of times shortcuts are taken, therefore safety is compromised. We have to be very careful about this implementation part. And first, about the implementation part, because we know what are the problems. The solutions can also be found out, but that has to be implemented on the ground properly. That's one. And secondly, after this has been implemented, it has to be monitored to see whether the implementation is working properly or not for at least 1 year. If it is not working properly, then some other solution will have to be done. Unless these things are done, how can the situation be?
One more question is, what role can technology play to improve the post-crash care? Means how can the emergency response time be reduced?
Yeah, I touched on it briefly. See, we have to have a network of emergency response systems for major highways, for minor highways, and the requirements may be slightly different from the national highways to the rural roads because the nature of travel is different. But we have to have a network, and thankfully we have started doing that with the response system. With there is technology available where automatically it can go to the control center, information can go to the control center. You don't have to dial in physically. These things are available now. And then the response system has to be there and within certain distance, within say 50-kilometer distance or even less, so that a vehicle with trained personnel can reach on time. And then the training is required. It is very important to have properly trained and skilled people in the ambulances, because how you handle an injured person can either save life, or that person can die or can be paralyzed forever in life. So all these trainings are required. The systems are going to be integrated, and then we have to have the technology, which is available, by the way, to have the quick response. Thankfully, we have started work.
Okay, we are almost out of time. This is the last question about Vision Zero. Is it achievable in India in the next 10-20 years, or does the scale require a modified approach? The scale of the problem require a modified approach.
Yeah, I'm coming to it. Vision Zero is a goal, right? Our first thing is, as I said, we have to reduce by 50%, everything by 50% by 2030. That's what we have committed to it. We signed on that in the international agreement. The first goal is to have 50% reduction in total number of crashes, total number of deaths, total number of injuries by 2030. Okay, and that's nowhere close to Vision Zero. Vision Zero will take some more time because we have to take a lot of action for that. Okay, so I'm not seeing Vision Zero happening within the next 5 years. It will take time. But the first goal is to get the reduction by 50%. We have already accepted that, signed.
Okay, I think we won't be taking any further questions. Thank you so much, Mr. Suvendu, for such an insightful and thoughtful session. Your perspectives on integrating audits, analysis, and safe system principles have shed light on how strategic planning and safety frameworks can transform our mobility systems for the better. We hope our audience found this session valuable and inspiring. For those who joined in late or wish to revisit the presentation, the recording will be available shortly. This was the 6th edition webinar of the Smarter Conversation series presented by AMNS India's Magnelis, where we continue to explore ideas that build and insights that inspire. Thank you for being with us today. We look forward to seeing you again in our next edition of Smarter Conversations. Until then, stay safe, stay inspired, and keep building smarter futures. Thank you.
Thank you, everyone. Thank you for listening. Bye.